So dear audience, in my presentation, I will focus on the geodetic view on the preparing of the documents and the models of cultural heritage object. So we as the surveyors or as geodesists are one very important, let's say, stakeholder within the process of preparing all this documentation and data. And starting with some introduction, I will at the end show a few cases which types of technology and methods we can use for creating the documentation. So starting with why we need to document the cultural heritage objects, we heard a lot about it in previous presentations. I'm sure that this will follow in the next presentations as well. So I would rather skip that and focus on our role, surveyor's role, or our task in preparing the documentation and the model of the cultural heritage object. So we are the one who can at least support the others to do that or to do it by us, to measure the exact dimensions of the objects, to interpret the material, so to capture also the very detailed parts, ornaments, and similar. Then to create the metrical images of the objects, to prepare the 3D models which are topologically correct and prepared. And finally, also to monitor and maintain as the status of the object of cultural heritage. Together also with the position the object itself into wider surroundings with water, let's say vegetation and other things, relief and so on. And while we know that we are the one we can provide all these things, we sometimes have the problems with the investors' expectations. In some part, this is because of the lack of the standards, which Professor Ioannidis mentioned before. So usually when we ask the investors what kind of data do you need for documentation, they said, we want to have the highest possible accuracy, which would be fully detailed and fully completeness. But for us, selecting the technology and the methods, we cannot do something maximum possible because we are limited with the possibilities of technology and also with some other issues in capturing. The cultural heritage objects usually are very complex with a lot of rounded parts, with different heights, towers, and so on. And they are sometimes on very difficult places where it is difficult to access on the high rocks, in the water area surrounded with dense vegetation and so on. And for us, it's extremely important to know if the final needed accuracy is 1 centimeter, 5 centimeters, or 1 millimeter. It's extremely important. We need to decide which technology and which method we can use to get the data that investor really need to have. So there are quite a lot of possibilities and of possible technology we can use for different processes, different phases in preparing documentation. First of all, one task which is usually not really known for the others, it's establishment of the basic surveying network. We need to do it initially in the beginning before preparing all the others, because only with the exact measured geodetic network we can assure the right dimensions of all surroundings of the objects. And only with this we can then position the objects into the global surroundings and global environment. And here, for instance, we have two different technologies. And it depends on the accessibility, on the detainees, on the final accuracy, which technology can be used. Then for detecting the object dimensions, again, we have at least four technologies available, from the, let's say, old-fashioned one, tachymetry, to 3 remote sensing ones. Together with laser scanning, which was already mentioned today, we can also use technologies using the photography. But we can do photographs from the ground or using the UAVs. And again, 2 of these technologies can be then further used also to get the images or to get a detailed look of the object itself. And following the capturing, we have then the procedures of creating the model, the raw data usually is the point cloud, but the point cloud is only the raw data. It needs a lot of further work on it to get the objects, the 3D models, which have to be estimated in the question of the quality, not only positional, also the semantical quality and so on. And then to add the image testing, image texturing. And finally, there's also many possibilities. We already heard about it also, how to present this final documentation to the audience, to the investors, to the tourists, to the maintainers. So we have quite a lot of different options also here. And now let's go to few examples, two case studies, different ones, where I will try to just briefly show you how we can select the different methodology or technology according to the selected object. First one, you can see it's quite a simple object. It's a chapel on the Krvavec. It's the ski resort here, just above the Ljubljana flatness. So relatively small object, easily accessible. So we use the GNSS array for determining the position of the control points. Then tachymetry to measure the basic, let's say, geometry of the building itself. And then with photographing the objects, both from the ground, so to get the horizontal images, and both from the air using UAV to get the oblique and the vertical photographies. We could altogether create the 3D model, which you can see here looks pretty the same like the original image of the object. Of course, it's pretty simple. It was not really a big problem. And in this case, we have a lot of possibilities how to do it. Next case shows another castle, Castle Lobnik, which you can see it's a little larger one. And here the main difference is it is not so easy accessible like the previous one. It's positioned on the quite high rock. It's about 10 meters of height rock. But luckily, here around, we have almost free without any vegetation area. So we could use, again, the UAV here. But first, the most important thing was to establish the geodetic network. Here you can see the 6 control points. Okay, they are on the, you can see them here. Few of them at the castle, so at the top to the highest level. Few of them down there to get also this precise and exact dimension in the vertical scale as well. And then finally, you can see the distribution of the photographs which were taken around the castle. From them, first the point cloud, and then the thin mesh model, and finally the complete digital 3D model, which of course can be also printed as a 3D model. So for some of the users, it's easier still to work with a practical, to the physical model, not with a virtual model, which he can use on the computer. And another possibility, we also heard about the possibility of augmented reality, where we can add also the other data or show to the user something additional, something else to the existing object. So here, using some gaming software, we prepared the augmented reality views on this, from this castle. The next case, the third castle, Castle Brestanica. Again, the little more complex one, the larger one. And in this case, we had some problems with the definition of the control points, because we can see this castle here, in contrast to the previous one, is surrounded with a quite a dense vegetation, which of course makes some limitations to the GNSS survey. And so in this particular case, we had to remove one of the control points, where the position accuracy was not good enough for the further procedures. And then, again, here you can see the distribution of the images. Here, since the object is larger and the area is larger, here you can see that in this case we pre-planned the mission of the UAV. So UAV went in the pre-mission, pre-prepared mission to make a capture photographs of the area. And again, some results of the survey. The point cloud consisted altogether of 33 million of the points, which is quite normal nowadays. You are, I'm sure, familiar with that amount of data. We are always working with the big data. And of course, again, thin mesh, digital 3D model, and 3D print. And also then this creation of the surface model, 3D model geometrical corrected, which can be then as a basis for the further documentation and positioning of the castle into wider surroundings. And finally, let's move to the last, the fourth case. Here is the Ljubljana castle. Just here, we heard about Ljubljana castle already at introduction today. So Ljubljana castle is a larger one. It's pretty complex, but here, instead of photography, we use the terrestrial laser scanning, which can be done from 3 different stands. So previously, all these stands were measured, positioned using the geodetic surveying technologies. Here we can see now the differences when we are using terrestrial laser scanning, comparing to the photographs. We have a lot of parts where we have lack of the data because we cannot position the laser scanner or so many places like making photographs from UAV, for instance. From UAV, you can make a photography from every single point, but here we are limited only in the stance of the laser scanner. But of course, another advantage of this type of data is much more detailed presentation and direct metric information. So if we really need to have exact metric information, this technology can be used. And then, of course, from this data, you can see topologically correct plans and some other possible application like shading analysis, again, 3D print, and so on. So to conclude with this, let's say, as I mentioned at the beginning, surveyor's view on preparing documentation and modeling, it was obvious that we usually have to combine the different technologies. We have a lot of technologies. Most of them enable few important things, but to create a common joint model, we need to combine them, and each of them has to be very carefully estimated according to accuracy and other standards of quality. Even with that, we can at the end get the enough good documentation and models which can be used further on for different purposes. We heard about it. And of course, also the final outputs and products have to be decided. We also heard about that, also with the iceberg, which Professor Žarnić mentioned. So correct models with all the information, with all the important data from the authorities, investors, or maintenance, but only the most attractive things for the general public. And to conclude my presentations, be aware that really geometrically correct and detailed models of cultural heritage are the only guarantee for the long-time preservation and documentation. Thank you very much.